Welcome members, today we are going to see a lesson about orthogonal circles, but before we start, please don't forget to subscribe to the channel. Now, the idea is, what is meant by orthogonal circles? Now, orthogonal circles are two circles where their tangents are perpendicular to each other. Now, when we have, say, this circle of this equation, and this circle of this equation, you see that the tangent to this circle is here, and the tangent to this circle is here, but these tangents are passing through their centers of the opposite circle. So the tangent to this is going to pass through the center of the other circle, and the tangent to this is passing through the center of the other circle. Now, the distance between these two centers is d. So you see that the tangents are perpendicular to each other. Now, if I pick out this triangle here, it's going to be here, and there you see, using Pythagoras, this squared will be this squared plus this squared. I think that we are together there. Where d is the distance between the two centers. Now, if this is called sub 1 and this one is called 2, if they are orthogonal, it means that its center for this, you get the center for this, and then the radius, we shall square the corners of the center, then minus c1. Then circle 2 still, you compare, you see that the center is going to be a2, b2. Then the radius, you square the coordinates of the center, minus the c, the constant there. Now, where the distance now between these two centers, so this is center and this is center, we want the distance because that's how we find d. We know we are going to get this minus this, then squared, then plus the y coordinates, their difference squared. So, because they are orthogonal, it means that when you square the radius of the one plus the square of the radius of the other, it will be equal to the square of the distance between their centers. So, when you square this radius here, the square root will go. When I square this, the whole of this will go. So that's why when I square this, I have this without the square root. When I square this, the square root will go. If I square, equaling to d, but also d is squared. So when I square it, the square root will go away. So expanding this, we have this. If you expand it, this is a. And when we expand this, we have that. Instead, we are going to simplify. You see that this a is going to survive with that one. This one is going away, and this one is going out. So these ones, for them, they are going away. So the only thing we are dealing with is negative c1 minus c2 equaling to now this and this. And start the negative is common. If you divide through by negative, this is what we have. And now this is the condition for orthogonal circles, derived from the idea that the distance between their center squared will be the sum of the square of the separate radii. Now, from there, members, then an example is here. Show that the circles that and this are orthogonal. So members, all you need to do, you need to get the center. You see, you need to get this constant, then this, then their coordinates of their centers. So the center here, if we compare, is that negative 2a1 will be 10, because this one is going to be a. So that 9a1 is going to be negative 5. Then from here to negative 2b is going to be now negative 4. Now this is b1. Then it's that 9b1 is going to be a 2. So that's all we need. We need the a1, a2. So we have a1 and b1. So now we need also c1. We start from here. Our c1 is going to be negative 3. So that's all. Then we come, we need also a2, b2, then c2. Now it means that we are using this second circle. So from here, if I compare negative 2, a2, so it's that we have it already there. Then we set our condition. if these two circles are orthogonal, it means that so now we check. We have C1 as plus C2 equal to 2 into A1, A2, we have 1, then plus 2, B1, 2, then B2, B2 is 3. So this side we have 2 equal to 2, this will be then plus, this is 6 times 2, that is 12, this at R2 is equal to 2 at 2. And this shows that they are orthogonal, therefore they are orthogonal. So members, that's all we need so that they are orthogonal. Or some people still go on to get the radius of the circle, then they get the distance between their centers. So alternative, then you also put that alternative here. So that now, this, if you use now this direct, you need the distance between the centers, then the separated line. Meaning that now, from here, I can get my big radii squared. So big radii squared is going to be, if you now get this, the radius of this one, you say you square this, so this will be 25, then plus, this one is going to be 4, then minus 3, and this one is going to give you, this is 29 plus 3, that is 32. Let us see, what about R1? So this one, our R, but we need a square of it. We are going to square, so we are having 1, then plus we are squaring the coordinates. We are having 9, then minus 5. Right, it's going to be, so this is going to be 10, which is going to give you a 5 like that. What about the distance between their centers? So the distance between their centers squared is going to be now, we shall get now, negative 5 minus this, we shall be having negative 5 minus 1 squared, then plus, then we will get a 2 minus at 3, the whole square. And instead this one will give you, this one is 36. This is going to give you 36, then plus a 1, which will give you 37. So that is 37. Then you check. You check using this condition. So that this squared is equal to R squared plus R squared. So our this squared is that it's 37. Is it equal to R squared, which is 32, then plus R squared, the small one, which is 5, and you see that 37 is equal to 2. When you add that, you also get 37. So whatever method you use, all of them are going to give you the same answer. Don't forget to subscribe to the channel. I wish you the best. Sign out.